Right, now we're going to look at dealing with a right triangle and using the Pythagorean theorem, which is something that you're very used to using, but just a couple of reminders. Of course, your Pythagorean theorem is used to help you find one of the three sides of a right triangle. It does only work for right triangles. Big thing that you've got to remember is in your formula, of course, you have a squared plus b squared equals c squared, is that the C has to represent your hypotenuse. Of course, your hypotenuse is always opposite your right angle. So the A and the B are always just used for the length of the sides. Now, which one's A, which one's B, that's interchangeable. Okay, so looking at a couple of examples using the Pythagorean theorem. Okay, so the first one, I'll cover this other one up for just a minute. Okay, so as it states, it says to solve for x in each of the right triangles. Alright, so looking at the first one here, of course it is a right triangle, but your hypotenuse would have to be the 10. So when you're substituting your values in, the 10 has to be substituted in for C. The x and the square root 17, that would be your A and your B, and you have that option of which one you want to use. Okay, so I'm going to set this up then as x squared plus square root 17 squared is equal to 10 squared. Okay, so when I square the square root of 17, I get 17, and I square 10, I get 100, and then I would need to subtract 17, so 100 minus the 17 would give me 83. And then I take square root of both sides. Of course, when you're accustomed to using the square root property to solve equations, you know, it's been stressed to you to put the plus minus, but like in this case, it's only going to be the positive because you're looking for the length of the side of a triangle, so it's not going to be negative. Now just leave this in radical form. Don't change that to a decimal. Now, if you have a radical that can be simplified, then you are expected to simplify the radical. Now, what I mean, and I'm just going to make up a number here. So, let's say, for instance, that had come out to be square root 12. So, you remember simplifying, you know, you find a perfect square that will go into, in this case, go into 12. So, that would be 4. So, square root of 4 is 2. The 3's left underneath. So that's what I mean by if you can simplify this. I do want you to go through that process, but don't change it to a decimal and round it off. Like I said, I just made this up. That doesn't apply to that problem that I just finished. Okay, next. Now the next one, just kind of test your algebra skills a little bit more. Okay, so again, make sure you identify your C value first. So in this case, that would be the 5. So I would, of course, this is the A and the B, so which one's which doesn't matter. So I'm going to say that I have x minus 1 squared plus x squared is equal to 5 squared. Now, if you can square this in your head, that's great. If not, go over to the side, write it down twice, pull it out, and you're going to end up with x squared minus 2x plus 1. Then I'm going to bring down my x squared. Of course, square the 5, and I get 25. Now, what I have is a quadratic equation. So what we've learned with quadratic equations is you do need to have those set equal to 0. I am going to go ahead and combine these two terms, so that's going to give me 2x squared. And then I'm going to bring down the minus 2x. Now, if I'm going to set this equal to 0, that's going to require that I subtract my 25. So the 1 minus the 25 would give me negative 24. Now, you need to solve this. Actually, this one will factor. If it doesn't factor, you can always, use your quadratic formula. I'm going to factor out a common factor of 2 first. And then the trinomial that I'm left with will factor. And that would factor as x minus 4 and x plus 3. So if you solve x minus 4 equals 0, you get positive 4. x plus 3 equals 0 would give you x equal negative 3. Now x does represent the length of the bottom of this right triangle, so actually your answer is just the 4, because you can't have a length that's negative.